Um, Another thing is when we work with many companies, and when I go to these conferences, I hear people talk about this inspect. We found the failure. Yeah, but that's not the whole solution. Once you found the failure, you're actually going to have to plan the corrective action. You need to schedule it, and you actually need to repair it. We forget about those 3 steps sometimes. That's not even talked about. When I talk to guys like GE Digital, Aviva, Aspen Tech, and these guys, they're just like, oh, we found it. What if you're a supervisor and you have an area and you have 1,500 work orders in your backlog? It's not uncommon for a steel mill or something like that. You've put on one of these solutions. What's going to happen to your number of work requests, do you think? They're going to go up, right? You're going to get more alarms. And if you don't do it right, you're going to have something sound like a pinball machine just going off with a bunch of alarms. Bing, 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 bing. So people lock it up in a closet and just close it and throw away the key, right? We don't use it. This great tool that we have. Because you already had 1,500 work orders you need to take care of. Now you get 2,000. Great. That's a problem. Now, this is number 4, right? There's a hazard. If you don't train the software correctly, you're going to get too many alarms. You're not going to understand the alarms. So when we start working with Aspen Tech, the first thing they wanted us to do is say, you have a bunch of reliability engineers. Yeah, we do. So can you help us program what they call agents, meaning the sensors and the sensors sense data to the agents, right? And say, can you train these agents and show them what the failure modes are? So yeah, that's no problem. We have all the failure modes, we have the databases and so forth and so forth. But they quickly realized that that's not what we're supposed to be used for. What they're using us for now is what we call planning and scheduling, to take care of all the alarms that turns into, in SAP, turns into notification or work requests, whatever it may be. That's where we work, to take care of all the alarms and then help the organization integrate those alarms as notifications or work requests, plan them, schedule them, and see if we need to do the repair work. Another thing is, many people have talked about this, if we don't have the bill of materials and the parts, because a machine does not break down, right? A piece of equipment does not break down. It's a component that breaks down. So you need to have the components in your CMMS and in your database, otherwise you're never going to find the failures. I guarantee you that. Some cool stuff we can do is we can supposedly find failures earlier with these sensors. By AI and learning, we can find failures earlier. We have seen that with some of the vibration data that we have. This happens to be Aspen Tech, and we look at net suction positive head, right? NPSH. And we looked at that and look at a percentage, and we start seeing that changing, that basically the pressure is changing. So we see that over time, and we can now catch the failure earlier. And that's pretty cool, because you can't have a guy who's standing there looking at the pressure gauge, right? So some of these things, we're going to be able to find some failures. If you design the systems and select the right sensors, you're going to be able to find problems earlier. That's great. Good stuff. The next thing, which I think is the biggest opportunity, and this is just my opinion again, but if we can take more than just temperature vibration, and which I know several of these companies out here can do, but we may not do it as often. I may not see it, but it's definitely an ability. So if you think of a pump, there's 2 bearings in the pump, 2 in the motor. We can do the temperature vibration on those. But what if we start adding data like seal water pressure, seal water flow? I start looking at, of course, discharge pressure from the pump, inlet pressure from the pump. Maybe I even take the position of the valve. Now I teach the computer, well, they're going to learn very quickly. When you close that outlet valve at 68%, maybe I get cavitation in the pump, right? And I start adding these variables together. That's not something humans are very good at. And some of that data is on the operations side, some of it's on the maintenance side. But if we can join these two and start looking at the spectrum of data, we're going to learn some pretty cool stuff, I think, going forward. So definitely a lot of opportunities, I believe, in this technology if we use it in the same spot. What I'm struggling with today is the business case. So watch out. What I see with asset performance management when we talk about this is the business case that I've seen is somebody saying, look, we put this system on, whatever it is, right? I'm impartial, but if it's GE Digital, Aviva, or whatever it is, we put the system on, we found these failures, and we save this much money, break downtime money. Yeah, but they're comparing it to not doing anything. I mean, all of you guys have some type of preventive maintenance, predictive maintenance in your plants, right? So to get the business case, you have to say, look, we have to compare it with manually having a guy going around doing vibration, look, listen, feel, smell, taking thermography readings, whatever it may be, versus automating it. Now the business case to me has been very hard. There are some, but it's very, to many here, it's very expensive technology. Some have less expensive technology, but then you're limited in what you can do. So some will take temperature, vibration, give you the software, give you the sensors fairly cheap, which is great. But you then limited, you can't do a whole lot more than just those two, right? But the business case I struggle with, I have limited experience. I've been doing this the last 3 years. We've been looking at these business cases, talking to the vendors. I think there are business cases, clearly, but it has to be something that causes big downtime money, right? It has to be something we can measure with the right stuff, et cetera, et cetera. There's a number of parameters we can talk about. So, summary. I think it's a great tool. Obviously, we need to get on the bandwagon and start learning how we can use this tool. The technology goes very, very quickly. But the fundamentals of maintenance management will not change, at least not from this perspective, from what I'm talking about, automated inspections, right? I mean, you're still going to have to plan the work, schedule the work, and actually having craftspeople that are skilled to do the repair in a planned and scheduled fashion. The plants I'm working with, I'm going to a paper mill in Sweden. That's why I'm here. So I stopped by doing this presentation. But we're working on the planning side. I mean, how do we really get planned work to the craftspeople? You know, and what does that mean? And who does it? Who gets the bolts? Who actually writes the job instructions? You know, can the planners even write the job instructions? These are things we're working on. These things have not, some people argue that AI can do it. Maybe. I would be hesitant to see that, but maybe it can help, I think, for sure. Right? Already, maybe it can help. I haven't seen it, but maybe, I'm sure it will sooner or later. Condition monitoring, it has very big potential, but remember, it's not covering everything, right? It covers, to me at least this day and age, you can't measure everything with a sensor. There's a lot of stuff, look, listen, feel, smell. Now you say, oh, here's an old guy saying we need to go out there, look, listen, feel, smell. But think about it logically if you don't believe me, but there's a bunch of stuff you cannot find with a sensor cost effectively. You just can't. Master data obviously has to be right. Everybody says that, right? Whoever you talk to. You can't just have pump. You have to actually know, well, what kind of coupling is it? Because a gear coupling has a different failure mode than a tire coupling. They're different. Or a jaw coupling, they fail differently. You need to know what kind of seal. Is it a pack-in or mechanical seal? I need to know. If I don't have that data, forget about digital transformation. So advice is to start working on it because somebody's going to ask you to do it sooner or later, so you might as well clean up your data. I think that it's tough. Select the right equipment to get the ROI, clearly, but it's not a given.